What's up, Algebra 2? Here we are with the first day of 9B, Day 1, Law of Sines. The law of sines is going to help us solve these triangle problems that are not a right triangle. Okay, all our sine, tangent, cosine stuff from earlier was with a right triangle. The law of sines works on any triangle. And what it looks like is this. You're not going to necessarily have all three of them in a row. You're probably only going to have two pieces. But the ratio of the sine of the angle divided by the side length of the side across from it will be the same for all three of them. So sine of angle A divided by side length A, that ratio will be the same as sine of angle B divided by side length B, which will be the same as sine of angle C divided by side length C. And you can flip it, so the side lengths are on top and the angle parts are on the bottom. Okay, I would put it, so if like you're trying to find a side length, I would have the side lengths on top in your ratio. And if you're trying to find an angle, I would put the angle stuff on top. Alright, solve for all the sides. Or all the missing pieces. Solve for all the missing pieces. Okay? We have 34 degrees in this corner, 39 degrees in that corner, and 12 for this side. Okay, we do not have a matching set. I have angle A, but I don't have side A. I have angle B, but I don't have side B. I have side C, but I don't have angle C. So I'm stuck. I can't do any of these. I don't have a matching set. Well, think back to geometry. How many degrees are in a triangle? 180. And we have 39 and 34 already. So angle C equals 107 degrees. Now I have an angle with a side across from it, and I'm going to use that to set up the rest of them. Okay, if I want side length A, it's going to go over sine of 34. And it's equal to R12 over sine of 107. That's why you have to have a matching set. Okay, A over sine of 34 equals 12 over sine of 107. We're trying to get A by itself. Let's multiply by sine of 34. Those will cancel. 12 times sine of 34 over sine of 107. Now the fun part, typing this in. Okay. First, make sure we're in degree mode. Mode, radians or degrees. We want degrees. So if you are on radian mode, slide over to degree and hit enter. Second quit. Okay. 12 times sine of 34, close your parentheses, divided by sine of 107. Close those parentheses. And we got 7.0. 7.0. We'll round to 1 decimal today. Okay, we got side A. Now we still need side B. Side B is across from 39 degrees. And again, I'm going to come back and use this 12 over sine of 107 because it's nice numbers that weren't rounded. It was part of the original problem. You could use the 7.0 or just 7 there, but that was kind of rounded. It was 7.016920. Not a lot of numbers there got dropped off, so it probably wouldn't affect your final answer, 07. But you still need to be watching out so we don't lose So if you used one that got rounded a lot more, it could affect your next answer, which is why I'm going to go back to this one. All right, so we're going to multiply that sign up there. All right, practice typing that in. 12 times sine of 39 over sine of 107. And we get 7.9. All right, we got it all filled in. We're going to skip the middle one. We're going to drop down to the bottom one, because you have to sketch the triangle yourself. Okay, do not waste a bunch of time trying to draw a perfect triangle. Okay, I don't pay any attention to that stuff, and I'll just draw my triangle. Boom, boom, boom. Okay, drawing it to scale does not matter. Okay, just having a triangle down so we can label everything and then see what's missing and solve for those spots, that's what matters. So don't sit there and try to draw this to be perfectly 80 degrees. I just usually go with that triangle. It's basically an equilateral triangle. And then I label them A, B, C. And then I fill it in. Okay, side A, 14. That's across from angle A. All right. So first thing I notice, 40, 80, we could do a little triangle math there and come up with our third angle. What is it? 60 degrees for angle C. Okay, and now we're ready to find our other two sides. All right, let's go C over sine of 60 equals 14 over sine of 80. We're going to multiply both sides by sine of 60. And what do we get? 12.3. For our last side length, side B over sine of 40 equals 14 over sine of 80. Okay, take a look at that. Think about it, think about it. Okay, we're going to multiply by sine 40. And we should be getting 9.1. All right, so hopefully we're okay with that type of triangle, and there's two angles given. Okay, you can usually just use the triangle math, subtract from 180 to find that third one, and then we can do two law of sines with the sides on top to find the missing sides. A little awareness level geometry flashback. The SSA triangle case. How come we could not use SSA for our triangle congruency theorems? Well, it's because you have many or multiple triangles that are possible. If angle A is acute and A is less than the height, there's no triangle possible. Okay? Because A can't get back down to the ground. If side A is exactly the same as the height of the triangle, you have a right triangle. If A is bigger than B, okay, bigger than B, it's going to have to be bigger than H, then you have an obtuse triangle, with the obtuse one being up here instead of down there. If, this is the tricky part, this is why you can't do it. If A is bigger than H, but still smaller than B, we have two triangles possible. You could have the big one on the outside, or this leg could swing around and be over here and have this little skinny one on this side. So there's two triangles possible sometimes, so it does not guarantee that it's congruent. Okay? It does not necessarily guarantee that it's congruent. So you just have to be aware of that. You'll do more with pre-calc, do more with that in pre-calc, and having to figure out which situation you have. And if you have the two triangle situation, filling out all the information for both possible triangles. Okay? Let's look at solving one of these with sine inverse. On the front side, we always had two angles and a side. So then we could just use the 180 triangle sum theorem to get our third angle, and then we just do the sides. What if you only have one angle to start with? Okay, if you only have one angle to start with, and because we're not doing this stuff, these will all be nice ones that are going to end up being one triangle. If you only have one angle to start with, you're pretty limited. Okay, here's my matching partners. My only other piece of information is 10. So across from 10 is angle B. So we're going to do sine. We're doing the sines on top because I'm trying to find what angle B is. Over 10 equals sine 80 over 14. We're going to multiply by 10. I'd put your times 10 in the front so you don't confuse it and call it sine of 800. As I say that, I'm going to write sine of 800. 10 times sine 80 over 14. How do I get angle B? I have sine of angle B equals this mess. How do I just get B? With the sine inverse. We're going to do the sine inverse of both sides. Okay. Sine inverse will give you an angle back for an answer. Let's see how we type that in. Okay, sine inverse is going to be second sine. I'm going to go 10 times sine of 80. Make sure we close those parentheses up. Divided by 14. And now we close the outside parentheses up. 44.7 degrees. Some people like to ignore the sine inverse and do that stuff first. And then do the sine inverse of that decimal. Second sine, second answer. And that will take the previous answer and we'll substitute it in there. 44.7 degrees. So the good news about the sine inverse stuff is that you only have to do it once per triangle. That's going to be 44.7 degrees. And now I can do the triangle sum theorem, 180 minus both of those. Okay, and then we should get 55.3 over there. Oh, sorry. 55.3 over here. And now we need a side. So now we're back to having the sides on top. Side A over sine of 55.3 equals, I'd go back to the original one that's not rounded, 14 over sine 80. Alright? And our A should be 11.7. Should be 11.7. So the sine inverse, you might have to do it one time. Then we can do our triangle sum to get the third angle. And then we can find our third side. Okay, let's see if you can do that with this one over here. Go ahead and push pause and see what you can do. Alright, welcome back. hopefully you got these answers. Starting it off, we have, this is our matching set, and the only other thing we have is 8, which is across from angle T. So sine T over 8 equals sine of 53 over 17. We're going to multiply by 8 and then do sine inverse to get 22.1 degrees. Then we can subtract our angles from 180. That'll give us our third angle, 104.9. And then we can set up a regular one with the sides on top to get what our missing side A is. Okay, a lot of new stuff today. Well, just one formula, but going 2 different ways. It's brand new. It's probably going to hurt your head a little bit. Best way to get better at it is to do it. All right, if you need to rewind and check out one of those examples again, feel free to do so. And good luck on your homework.